Hello, today we are going to work through a quick proof that the power rule works for negative integer exponents also. Now last video I worked through a proof of the quotient rule, and that's because we are going to have to use it for this proof. Now, as you should remember from algebra, a number k to the negative p is equal to 1 over k to the p. So that should make sense because if you multiply this number, k to the negative p, times k to the p, those would cancel out and it would equal 1. Because that would also equal 1 over k to the p times k to the p. Those would cancel out and they equal 1. So that's kind of how it works. Okay, so let's continue with that established. So what we want to do is take the derivative for a function that 1 over x to the n, where n is a positive integer since we're taking it for a negative integer. Okay, now we're going to use the quotient rule to solve this because it has one number divided by another number. Okay, so as you may remember from the last video, the quotient rule states that the derivative of a function f of x divided by a function g of x, the derivative of that is going to be equal to the derivative of f of x times g of x minus the derivative of g of x times f of x. All that will be divided by g of x squared. Okay, that's the quotient rule, and like I said, I proved it in the last video, so if you want to go check it out, it's pretty interesting. So, let's continue. Let me switch colors. So, let's move down here. So we have the derivative of 1 over x to the n, so that's going to be equal to, so that's kind of like 1 is f of x, and x to the n is just g of x. So let's take the derivative of f of x, that's just going to be 0, so it's 0 times then just g of x, which is x to the n, so it's times x to the n, which that's just going to equal 0, minus, it's going to be the derivative of g of x times f of x. That's going to be 1 times, and this I already proved for positive integers, so that's just going to be n times x to the n minus 1, and that's just going to equal negative n times x to the n minus 1. And then remember for this we need to divide by g of x squared. That's just going to be dividing by x to the n squared, or just x to the 2n. And remember that a number k to the p divided by k to the m, or that should be k to the m, is equal to k to the p minus m. Okay, so then we can have it such as negative n times x to the negative n minus 1, and that should make sense. So this is the power rule. Should we write that? So it's negative n times x to the negative n minus 1. That's just the power rule because n is the exponent. So that's how you prove it. So thanks for watching, and come back next time when I'm going to do implicit differentiation. Thanks for watching.